Welcome back, folks. We have a special treat for you today. We have a special guest presenter doing a couple special cases of the law of sines. Take it away, Jake.
Hello, everybody. It is an honor to be featured on one of Mr. Vass's award-winning videos. It's like a dream come true. But without further ado, I'm going to get started on these problems we got here. So, all right. Given a triangle with alpha of 10 degrees, A equals 5 and B equals 8, show that there are two distinct triangles which meet this criteria. So first of all, we'll just, on this top triangle right here, we're going to fill in what we know. So we got, we'll say this one's alpha, we got this one's at, oh, that's a highlighter. That is not a pen. Oh, here we go. Okay. Perfect, that's better. Okay, so we got that this one right here is, we'll say that's alpha, so alpha is 10 degrees. And if alpha is 10 degrees, then the side across from it, A, we were told is 5, so we can put that right there. We know that B is 8, so we can make this side 8. And then to fill in the other angles we have left over, we know the one that's across from B, got angle beta, is this one right here, because it's right across from it. And then we'll have side C, and here we go, theta. Alright, so the law of sines lets us know, well, first of all, let's see, what are we trying to find first? So what the other things we need to find in, fill in is beta. So we want to find beta, and that way we can find all three of these angles. So the law of sines is going to tell us that sine of 10 over 5, the one across from it, is gonna equal sine of beta over 8, the one across from angle beta. And then I did this on calculator earlier, so I'll just simplify that for you. So that equals roughly about 1.73. It's a whole big chain of numbers, but you can follow along on your calculator as well. You don't need to write out those big complicated numbers. Is going to be equal to, same thing on the other side. And then if we go further by simplifying what's on the left side, we'll get roughly 0.034.35 is going to still got the same thing on the other side. Don't worry, we'll get rid of it soon. Is gonna end up, we'll see, so if we can multiply both sides by 8, we'll get sine of beta by itself. So we'll end up with now we got sine of beta right there. So our goal here initially is to find beta, but sine of beta isn't really going to totally tell us, but what we can do is we can undo the sine on the right side by doing inverse sine or arc sine of both sides. And we will do that like so. So arc sine of what's here on the left side, this 0 point. And again, on your calculator, you can be typing in that longer chain or things like that to be more precise, but I don't feel like writing all that out. And if we do this here on the left side, type it into our calculator, what we're going to end up with is 16, roughly about I got about 0.13 degrees. So we can say that beta equals 16.13 degrees. And we can give that a good little, now I want the highlighter. Give that a little highlight right there. Oh, how nice. Okay, so we can write that in here. You know what we'll do? We're just going to erase this right here. Perfect. We'll erase that. We'll fill in beta as 16.13 degrees. Okay, and then we can find our third angle just by doing triangle sum. Easy enough. So what we got? 180 minus 10 minus 16.13 is going to tell us that the theta is going going to equal 153.87 degrees. So that's a much bigger angle than those other ones. So we can fill that one in. Oh no, we'll erase it right there. Okay, so then we're gonna also, so what's left to find? We need to find side C is what we still have left to find, right? Okay, yeah. So we can do what we did to find beta. We can just use the law of sines again. So this time, even though we have two sine ratios we can work with because we know B and beta and we know A and alpha, we might as well just use A and alpha again just for sake of keeping things simple. And I write kind of big. I'm going to need to give myself some more room. Okay, so we'll do C, side C, over sine of what we now know is the corresponding angle, 153.87, equals, and then we go back to what we had before. We got 5 corresponding to alpha, which is 10 degrees. And the reason why, there we go. I don't know why it jumped around me. The reason why I knew, or I decided to put the sine on the bottom and the side length on the top is that I think it's easier to do it that way, because this way you're putting, if you put the variable on the denominator, it just makes things more difficult, because then it's just more complicated to be dividing by a variable, multiplying by a variable in the end when we simplify. But it's easier, since we know both of these signs, to put these on the bottom. That way when we multiply the right side by sine of 153.87, it's a lot simpler because we know what that is. So it's basically just multiplying it by a number, and you'll see what I mean in a minute. So we're going to do and I'm just going to pause the video right here because you can probably do the simple math on your own. You don't need to see me go through it again and all that so on. 1 second. And you should have gotten that answer simply by just simplifying this and then multiplying the right side by sine of 153.87. Because to undo the division on the left side, you just do multiplication. And that's why it's easier to put C on the top, because again, you know what both of the sine numbers are. It's a lot simpler. So with C in hand, we can go back up to our triangle, and we can replace this with our answer, which we said was 12.68 roughly. So that's a triangle right there, boom. But if we go back to the question was telling us that we had to show that there are 2 distinct triangles which meet this criteria, and this is only 1. So why is there 2? I'm going to show you why. And I will do so using this little unit circle that's been sitting over there for this whole video. So the reason why there's 2 is that there's 2 angle betas, which, keep in mind, beta is this angle right here. We changed the name of it. And the reason why there's 2 of them is because when we were doing the first part of this problem, and we did arcsine, and I'll highlight it in a different color, down here, when we did arcsine, down here to get our answer, the thing is that, you know, a sine ratio is going to have 2 solutions, and I'll show you what I'm talking about. So we'll use a nice blue color. So over here on this unit circle, we ended up saying that after we determined that beta was 16.13 degrees, and I'll fill that in right here. Let's say it's roughly about right there. It doesn't need to be exact, showing a model. The point is, because we use a sine ratio to get that, that also is true. Sine also equals that over on this part of the unit circle as well. Because again, sine would be shown right here. You know, these are both the same. They're both positive and they're both the same. So the thing is, we need to account for both of those angles. Now, the math version of doing this, just in an equation, would be if we took 180 and subtracted, you know, the angle. And a lot of you probably already know to do that, but I was just going to show you, you know, to kind of show you why you do that. So right here, this is 180 degrees. And so the reason why you subtract that original angle is because keep in mind is that these two guys right here are both the same angle. So essentially, if you had, you know, 180 was this whole piece right here. I'm just going all rainbow on this problem. It's a blast. To get to this point, you can get there by, again, I'll fill it in again because this is the same thing right here. This angle right here is 16.13. I'm getting messy. You could get to this point by simply just subtracting that part back. So you're kind of like, almost you're kind of like ratcheting it back to that point right there. Would be a reason why, you know, you would subtract from 180 to get the other angle. So in that case, this other angle ends up being, because we said what 180 minus 16.13 is going to end up being 163.87. That is the second angle beta. So now we're going to have to go and plug that into our second triangle that we're creating, our other triangle, which this triangle includes beta 2, the other possible beta. So other possible beta is, and we'll keep beta in the same spot, keep everything in the same spot just to make it easier to see, won't get too confused. And then side B is still 8, so we still have 8 across from angle beta. We still would have this, we're not going to change that, we're going to have angle alpha is still going to be 10 degrees. We're not going to change that. And then side A is still going to be 5. What is going to change because of this different angle for beta is the third angle and side C is going to change. So in this case, for this triangle, the third angle is going to actually end up being, well, we're actually going to find it simply from doing the sum angle theorem again, just by subtracting from 180. We'll subtract 10 degrees, and then we'll subtract 163.87. So I'll scroll us on down. Here we do it in the space on the left. So we would do 180 minus 163.87 minus 10 is going to leave us 6.13. So we could fill that into our triangle right here. I'll give that a good little highlight just because. And then what we're going to do next is, and again, just like in the other problem, the last piece we have left is still this side C. And we can find side C just by doing the same thing, just doing the law of sine, nothing too complicated, nothing new. And we'll do, and again, we're going to do the thing again where I'm going to put C on top, because that's what we don't know, and it makes it easier to do. Sine of, this time it's sine of 6.13, because again, that is what is across from C. You know, because side C is right here, and that's what's across from it, is right there. We'll do C over sine of 6.13 equals, and we can just use the ratio from A and alpha, 5 over sine of 10. I'm going to pause the video again because otherwise I'm going to be writing long numbers all day. And you should have got that C equals 3. about 0.7. Let me fix that 0. It looks kind of messy. There we go. It's c equals 3.07, and you would have gotten that by, again, simplifying this side on your calculator and then just multiplying this side instead of dividing to get that answer. So we could fill that in up there. And I believe that then this problem is done and we have both of our distinct triangles. And again, when we plugged in the new, the second version of angle beta, remember we didn't change what the problem gave us up here. We still plugged in, 10 degrees equals this, this information didn't change. It just ended up making it angle beta was different, and then our side C and our third angle was also different. So we can go on to the next problem now. It's very exciting. All right, so then this problem is a little bit more of a special case, a little more interesting. So this says, given a triangle with alpha 10 degrees, same thing as last time, this time side A is going to equal 8 and side B is going to equal 5. This says, why is there only one distinct triangle? So this is what's different. It's only going to be one of them this time. We're not going to have to do a second one. We're going to find out. So why is there only one distinct triangle which meets this criteria? We're going to find out. So let's plug in the information that we know. So alpha is 10 degrees. And then side A crossing that is 8. And then we got that this time side B equals 5. We can put beta away from that. And we can put this and this. So we can start this problem off the same way as we've done before. So we'll take, using the law of sines, we'll do sine of 10 over 8, the side across from it, equals sine of beta that we don't know yet, and again putting that one on the top to make things easier, over 5, the one across from it. And I'll do the same thing as last time. I'll at least show you this one, but I won't go through all the trouble of doing every single one because you probably know how to do this by now, but a refresher isn't too bad. So again, on your calculator, it's going to, sine of 10 over 8 is going to come out to a number looking like that, a decimal like that. Same thing on this side, or 5. We're going to try to get sine of beta by itself by multiplying both sides by 5. Since we've got division on the right side, we'll undo that division, and we'll get something roughly like this. And again, that's after we multiply both sides by 5. Don't forget that. We'll get an answer that looks like that. Equals, now we got sine of beta by itself. Do the same thing we did last time. We got to undo that sign. So we're going to do, why does it keep jumping on me? Going to undo that with inverse sine or arc sine. Arc sine is going to end up equal. Again, when you type that into your calculator, you're going to get about 6.23. So we can say angle beta equals 6.23 degrees. Beautiful. So we can go back, plug that guy in. That's messy. That's pretty messy. Let me fix that. Let me erase that for you. Write it a little smaller. You deserve better than that, as Mr. Vass would say. 6.23 degrees. We can find the third angle by doing angle sum. 180 minus 6.23 minus 10 is going to give us 163.77. We can fill that guy in. Okay, so now all it's left to do is to find side C. Once again, not doing anything too different, but it's just this one's going to work out a little bit differently. You'll see. Only going to end up, so we'll get C over sine of that equals 8 over sine of 10, the one across from it. And again, if you do the math on your calculator, I'm not going to do all of it. You should know how to do it by now. I'm sure you don't need to hear me repeat it for a 5th time. We'll give you that for side C. And we'll fill it in. So now normally I'd be like, well, hold on. Like, no, in the last problem, we used an arc sine thing over here. We got to find a second angle for beta, but this problem is going to be different. There's only going to be one distinct triangle, and here is why. So I'm going to do the work we normally do to find our second beta. So keep in mind that beta is this one. I'm going to do the work to find a second beta, 180 minus the original beta, which is 6.23, is going to equal 173.77. You might be like, yeah, fine, go along, all good, la-di-da, totally fine. So let's pretend for a second like we didn't find, because let's act like we're doing this over again. We still don't know these two, because we're going back to the beginning of finding C in the third angle. So I'd be like, okay, so we got to find its third angle, so we'll just do, angle sum, 180 minus 173.77 minus 10. But wait, there's going to be a problem there. Because if we go all the way, that's too far. If we subtract 10 and 173, well, 10 plus 173.77 is about 183, and that's going to give us a negative number. So essentially what's happened here is that we have too much left over degrees. This angle is too big, is our issue here. So that is why there's only one solution.
Okay, Jake, thank you very much. Appreciate your help putting this video together. Again, folks, what he just showed you is that if we're given angle side information, sometimes we can have a single solution, and he showed you why, because if you look for the second beta, it ends up giving you a triangle where the angles, the alpha and the beta 2 add up to more than 180. And then he also showed you an example where given angle side information, you can come up with two distinct triangles. Thank you, Jake.